Well, I'm going to start off here in just a minute with a couple of announcements. Hopefully, if you did watch the video, then you know I'm excited to have you on the course. And I want to be here to help you guys. And so utilize that. We will start labs next week and we will meet in person, depending on which lab group you're in. So part of reading through the syllabus would have walked you through kind of our lab structure. And the most important thing there is next week, group A people. So if your name starts with if your last name starts with the first half of the alphabet, you're likely in group A. But double check the PDF on Blackboard. Group A people will show up to lab. We will do detecting signs of a chemical change in person. Group B people, you have some time to start working on the dry lab on density and conversions and specific heat. But nothing's due at the end of next week because the following week after that, then the group B people are going to come in. The group A people will do the dry lab on your own. And then everything will be due at the end of these next 2 weeks. So let me share my screen. I have a couple of announcements and I just went ahead and made kind of a slide for announcements for you visual people who want to write things down or just take a screenshot. So we'll walk through these and we're going to jump right into the lecture material. We're going to try to cover about half the slides today. You will need a calculator for today. So if you don't have a calculator, go ahead and grab one. And you're going to want one that can do scientific notation type stuff. So your cell phone's not going to be the best for that purposes. So if you need to grab your calculator, go ahead and do that. All right, I'm going to share my screen. Okay, you guys see my screen okay? Try to. I can only see 5 of you at a time, so we'll try to make this a little better. And then another thing I'll say is please make use of the chat function on here. If you have a question as we're going, then you can type it in the chat. You can unmute yourself and stop me. I encourage students to do that. If you think I'm moving through too fast and you want to slow down and go over something again, please don't hesitate. There's no silly questions. That's what all of this is for. So, all right, I think I got everything the way I want it. This first slide got a couple of just different announcements. So first off, you do need to buy some goggles if you're coming into the lab. We'll have 3 labs we do in person. So I have this kind of little advertisement here. Our department sells goggles and they are the over the glasses kind. So that's kind of nice for people who wear glasses. They're $10. They're only taking Cash App. That's down here and what their Cash App name is. So if you don't have Cash App, you'll need to get that if you want to buy from our department. I had a student send me a picture of their goggles though. They bought some at Lowe's. Lowe's has the approved kind of goggles for our course as well, if you don't want to buy them online. Somebody said they checked out that link on Amazon that I shared in an email and that they weren't going to arrive on time. So if you're looking for a place to buy goggles, Lowe's has them. Our department is selling them, and here's the times that they're selling them. The place that they're selling them is kind of down here on this map. So this is Mannion Hall right here, and then this is the Print Center. And it's right here where these arrows are. It's in the annex, which kind of connects the Print Center to Mannion Hall. So the ones at Lowe's, by the way, were $10 as well. So not really a price difference if you're needing goggles. So make sure you have those. I'm going to post another announcement. I'm going to post a discussion board question. So in Blackboard, hopefully you've all been able to navigate Blackboard okay. I had a student email me a really great question regarding precipitations. So in our first lecture, we talked about the 4 signs of a chemical change. One of those signs was formation of a precipitate. And they had a great question about it. So I'm going to post this question on precipitations to the discussion board. I'm also going to ask I'm going to broaden that question a little bit. And so please take note. I have not posted it yet, but by the end of the day, that will be there. And sometimes if you respond to these things, I'll count them as bonus points towards exams. So this first discussion board question, if you put a response on there, again, it's not going to have to be an essay. Don't write me like 4 paragraphs, but just give a thoughtful response. It will count towards 3 bonus points for exam 1, okay? If you just respond and participate in that discussion board question. All right, so that'll be for 3 bonus for exam 1. Lecture and lab Zoom links. I made 2 announcements on Blackboard. I just put the Zoom links there for easy access as well, in case anybody's ever scrambling to find a Zoom link. It's now going to be posted as an announcement on Blackboard. You can find it there for the rest of the semester. And then I also made a tutoring announcement. So if you are interested in having tutoring available to you this semester, if chemistry is like, this is the class you're most worried about and you're stressing already, please know that's available. And so read that announcement if you have any questions. There's also private tutoring options. I have people I can recommend who've really aced this class, who are willing to tutor students that I've talked to from previous semesters. Reach out to me. I'm also available to help you though. I have office hours. I had one person pop into my office hours yesterday. I'll be hosting an office hour right after this from 9:30 to 10:30. You can drop in, ask me questions. They usually go pretty well for students. So, and then due next week, there's just some things to keep on your radar. Anybody been able to check out, you please type respond to me in the chat. I can only see like 4 of you on the screen, but anybody been able to check out the assignments on mastering chemistry so far and get started on it? Okay, good, perfect, great. Yes, yes, yes. All right. The Chem primer, by the way, notice this is just for participation points. So don't worry, don't be freaking out if you're getting them all right or wrong. I just want you to do it, okay? It's just kind of to prime you and remind you what chemistry is all about. So that's, I'm gonna go through on Blackboard once everybody gets it done, once the due date is passed, and you will get all the points for that, 5 points, if you just do it, all right? Okay, we're starting a new lecture. We're still in chapter 1, but if you remember from Tuesday, I like to share different hikes that I've gotten to go on, or that me and my husband have gotten to do. And this one is a extra special kind of hike that I got to do. So I lived in Kenya for a summer a long time ago with a family, a really awesome, incredible family. They were missionaries over there for a long time. And this is actually where me and my husband met, in Kenya. We're both from Arkansas, fun fact. But we met in Kenya. So we got to hike this, it's called Mount Longnot, and you can tell it's a volcano. It's an inactive volcano. We got to hike the rim, okay? So there was a trail that, I don't know if you could see this red very well, but all the way around this rim region, we hiked it in one day. It was awesome. So not necessarily one that I'm saying you could go do unless you find yourself in Kenya one day. I would love to know if anybody's ever been to Africa or Kenya. It's an amazing place, but that was for sure one of the most spectacular hikes I've ever done. So, all right, we're gonna jump into measurements, and we're gonna also look at how to do some manipulation for some math purposes. Chemistry is very math involved, so that's one of the reasons a lot of people get frustrated or discouraged with chemistry, because the math involved. But I will tell you this, the stuff we're gonna cover today is stuff that you will use for the rest of the semester. So if you have questions, or if any of this does not sit well with you, please reach out to me, because this kind of stuff is really, really foundational for a lot of what we're gonna do. Measurements are important. We talked in the video Tuesday, I shared that chemistry is the study of matter. And when we're studying matter, there's different properties that we can look at. And I gave some examples of those properties. All right. Some examples that we had were mass, length. Can y'all see the red okay? Or do y'all prefer, it would be better for me to use a different color? Can y'all see the red?
Yes.
Okay. I'm going to continue with that then. Volume was one. All right, temperature. These are things we can measure. Any property that we can observe, we can usually measure it in some way, okay? So what we're doing here, a measurement is we're taking a physical quantity. Okay, a physical quantity, which is a property that can be measured. All right, and there's some examples. Now, I'm just going to read this portion of the next slide. When we measure matter, we're determining a physical property that the matter has. And measurements, what do? Why are they important? They tell us a starting point. I'm going to abbreviate, starting point for that property. So, because the next thing we talked about from Tuesday was that we don't just observe properties, we look at how matter changes. Okay, so if something's changing, if it's reacting or changing in some form, we will likely have to take a measurement beforehand and a measurement afterwards. Okay, now physical quantities, the most important thing I'm going to say on this whole slide is next. It is described by both a number and a, guess what? Anybody can guess what we're going to write in the blank? A number and a unit. Yes, someone wrote it in the chat. Okay. Here's what's going to happen all semester long. People are going to work problems on the exams. I'm going to see this, and you're just going to give me numbers with no units. Okay, grams, liters, meters. You're going to leave those things off. And I'm begging you now, do not do that. One, because it's going to cost you a lot of points. And two, I will have very little chance of following your work, even if you do it all correctly, if you leave units out. Okay, so units are letters. We abbreviate units a lot of times, and I'll show you all the abbreviations, but please remember to always put units with your measurements and your numbers. I'm going to illustrate to you why units are important. Okay, this is a silly example, but if I just told you I'm 66, okay, what do I mean? Okay, you need some sort of unit to go with that. Do I mean I'm 66 years old? I know I look young for my age. Do I mean that I'm 66 feet tall? Hardly. Okay. Do I mean that I'm 66 pounds? Not a chance. Okay. So just for example, you have to give more people more than just a number when you're conveying things, when you're conveying numbers. So numbers are meaningless without units. Okay. All right. What else do units do for us? So they tell us what we're measuring. Here's some more of the importance on units. The things that units do for us. They tell us what we're measuring. So if I told you that I'm 66 years old, that's a measure of time, right? So it tells you what you're measuring. They also give a reference point. One example I like to share here: when I was in graduate school, a lot of my friends were internationals from different countries, and I had a time learning about their countries. One of my best friends was from Iran, and over in the Middle East and in a lot of other countries, they discuss the weather and temperature in units of Celsius. Okay, over here we discuss it in units of Fahrenheit. If I told you that, oh, I keep my house on 70 degrees, you would know what I mean. Okay, to us 70 degrees roughly is room temperature. That's on the Fahrenheit scale, but not on the Celsius scale. Okay, the Celsius scale is different. Does anybody know roughly what room temperature is on the Celsius scale? Any guesses? Yeah, right around 18 to 20 degrees Celsius. Okay, so if room temp is right around 20 degrees Celsius, if my friend in Iran tells me, oh, in Iran today it's 54 degrees Celsius, knowing the reference point of room temperature, I can understand, wow, 54 degrees Celsius is extremely hot. If she just said it's 54 degrees, I would be like, man, that's kind of cold. Because on the Fahrenheit scale, 54 is kind of cold. So anyways, that gives you this illustration that they're a reference point, okay? Units help in that way. Now in the sciences, we use metric units and we use SI units, okay? Metric and SI units. So this table here, you're not gonna have to memorize all the units for both types. In fact, we're gonna mostly use metric units, but I do wanna let you know there are things called SI units. This is a system of international units. Why would that be important? Well, people do research all over the world. People do medicine, people do physics, all over the world, okay? And it's important that we can recreate someone's experiment or someone's research. If there's an advancement or a breakthrough in another country, and we want to bring those results or that product to our country, we need to be able to do that research, and we need to be able to replicate. And then publications in scientific journals or medical journals or nursing journals or whatever, they're usually with SI units or units that we can translate into our units. So this is the table that tells you the SI unit and the metric unit for different properties, okay, different physical quantities, which is over here on the left. And then it does give you a few equivalents. I'm going to give you better tables with equivalents. This will help you in some conversion problems that you're going to do with converting between different units. So you can see for mass, the SI unit is the kilogram, but for the metric unit, it's the gram, okay? And then it tells you over here, 1 kilogram is 1,000 grams. All right, so you can get an idea. Obviously, a kilogram is a lot bigger. For length, we have the meter for both, okay? And it's showing you the abbreviations with these as well. So on and so forth. I'm not going to spend a lot of time on this. I just wanted to introduce it to you. Again, we're mostly going to be using metric units in this course. On quizzes in the chat, I'm reading, on quizzes and exams, we have charts like this. You're going to have access to your notes. So if you read from my syllabus, I'm going to jump over to my syllabus real quick. I'm going to kind of point this out. I did it in the video briefly, but because all of our exams are online and I don't require the use of Respondus Lockdown, essentially this means your exams will be open note, open book, okay? So you have access to any of your notes. So if you want to come use these tables and things, by all means, they're available for you. I just ask that we don't use the internet. You should have all that you need in your notes anyways, especially if you're taking good notes. Does that answer your question, Bailey? Great. Okay, so that's just an intro to units. Now we're going to get into some scientific notation. So just to give you a rundown of what we're about to do, we're going to talk about scientific notation, how to multiply, add, subtract, divide numbers in scientific notation. Then we're going to talk about, we're going to look in depth a little bit about mass, volume, and length. And then we're going to talk about prefixes. And we're going to end the lecture today by working some examples of converting between units, okay? So scientific notation, hopefully this is a review for some of you. If this is brand new, that's okay. But hopefully it's just a good little review of something you're already familiar with. But what is it important for? Why do we need scientific notation? It is a way to make very small or very large numbers more manageable, okay? Instead of writing, a decimal with 5 or 6 or 8 zeros before or after, we can use scientific notation, and the numbers are just a lot easier to write, a lot easier to look at, and we still know what it means. So the general format here is this, and I'm going to explain this. It's A times 10, okay, raised to the power of B. So this is your exponent. We call that the exponent. And I'm going to call this here the units or the base number. Okay, I'm going to call this, and I know maybe using the word unit is confusing because I just used the word unit to describe letters that go with numbers. So I'll just call it the base unit. Okay, this is kind of your base number, base unit, base number. Okay, and then we have our times 10 to the power with our exponent. So your base number needs to be a number between 1 and 10. People forget this rule all the time. I usually get people with this on the very first quiz. Okay, so if you do some manipulation and you end up with 0.3 times 10 to the power of 2, that is not properly written in scientific notation because 0.3 is not a number between 1 and 10. Okay, so always make sure your base number is between 1 and 10. And then B, the exponent, this is going to match the number of places that the decimal moved. So what do I mean by that? Let's look at some examples. We have this number here, 83910. If I had to write in a decimal here, there's not one, but if you had to put one there to let you know the magnitude of this number as it is written, where would you put the decimal? Someone said after 8. That's if you're going to write it in scientific notation. I'm just saying as a standard number right now, where is the decimal currently? It's understood. It's not written. Yes, Emily said it after the 0. So right here. And we are going to move it to after the 8. That's correct. But right now our decimal is sitting after the 0. And that lets us know that this is 83,910. So now let's turn it into scientific notation. We want to convert this number to a number between 1 and 10. So I'm going to move the decimal. If I move it one place, I don't have a number between 1 and 10 yet. So I'm going to move it all the way like y'all were saying in the chat to right after the 8. So now I'm going to have 8.3991. You do or don't have to write the 0. It's okay. So now, if we're going to write B properly, I've got the times 10. What is B? B is the number of places the decimal moved. Well, I moved to the left 1, 2, 3, 4 places. Right? 1, 2, 3, yep, 4 places. So I should put a +4. Okay? Now, there's a rule that we just learned here. I didn't state it, but it was implied. If the decimal moves left, the exponent increases, okay? Notice that I'm not saying the exponent's always positive, okay? There are times you can move the decimal left and you still have a negative exponent. But here, typically if the decimal moves left, the exponent is always increasing towards the positive direction. All right, let's take this second number and let's turn it into a scientific number in scientific notation. So we see that the decimal is currently between these first two zeros. We want to turn this into a number between 1 and 10. So we're going to move it to after what digit? Yes, I'm seeing in the chat after the 5. 1, 2, 3, 4 places. So now I have 5.96 times 10. And this time my exponent is going to be negative to the -4 because the rule is if the decimal moves right, the exponent decreases. Okay, questions so far? So I want you guys to do some practice now. I've got this next slide, and I want you to take these numbers, convert them to scientific notation. We say these numbers as they're written are in standard notation, and I want you to write them in scientific notation. I'm gonna let you work on your own for just a second. And please remember that I'm asking you all to comply with my video rules. So please, I'm asking you to turn your videos on if possible. If you need to email me about a certain situation, then I can work with you. If you need to set your own background, go for it. But if not, I am asking everybody to have their videos on for lecture. All right, anybody have our first one? Looking in the, Kevin's got it, 6.5932 times 10 to the 4th. What about our second one? And Bailey said 8.37 times 10 to the -7. So let me double check. 1, 2, 3, 4, 5, 6, 7 places. It moved to the right, so our exponent's negative. Here, our decimal moved 1, 2, 3, 4, and it's to the left, so it's positive. Questions on that? Okay. So now we have scientific notation. I want you to convert it to standard notation. All right. So if you look here, we have a positive. It's like we're multiplying 7.41 by a very, very large number. If you just pop this into your calculator, that's an easy way to handle it. But if not, we need to take this decimal and move it back 8 places, this time to the right, to undo the scientific notation. So it should be 741. I think that was right. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So that's the number you should have. To undo this, we have a negative exponent. So it's like we're multiplying 3.021 by a very, very small number. So the decimal is going to move 5 places towards the left when you undo this. Okay, so you should get 0.12343021. Okay. If there's any questions on that, let me know. I can review it with anybody at any time. Okay, so that's just going back and forth between standard and scientific notation. Now we're going to look at how to do addition and subtraction, and then real quick we'll hit multiplication and division. All right, there's rules with these, so pay attention to these rules. For addition and subtraction, your exponents must be the same. All right, so let's look at this example problem. We have 7.41 times 10 to the power of 8 plus 4.32 times 10 to the power of 10. Okay, and what we're going to do is we're going to make sure our exponents are the same first, and then we can just simply add the numbers. So the example already fixes it for you. It takes this first number and it moves the decimal 2 places to the left. And if we're going to remember, if we're increasing the exponent, we want to increase this exponent right here from 8 to 10. So if we want to increase the exponent 2 places, we need to move the decimal 2 places to the left. Okay. Where did I get that? I just went right back up here to my rule. If we want to increase the exponent, we're going to move the decimal to the left. Okay, so that's what they did, and they came up with this number, 0.0741. Now we have times 10 to the power of 10. That matches our other exponent, 10 to the power of 10 over here. Now we can just add those numbers together, okay? 0.0741 plus 4.32 gives us 4.39, and our exponent, it matches. It's times 10 to the power of 10. So let's do an example here. I think I have this one as a poll question too. So I want you to take a minute. Look, I'm going to give you just a little bit. I want you to try to finish it on your own. Remember always your base number has to be a number between 1 and 10. Okay, remember that. So you need to ask yourself something here. Which one do I want to manipulate? Do I want to take this first number and make the -5 match the -8? Or do I want to take the -8 and make it match the -5? Okay. I'm going to pick the second number, the -8, and I'm going to make that exponent match -5. So first off, we need to say, do we want our exponent to increase or decrease? We have currently a -8, and I want to make it a -5. So do I want my exponent to increase or decrease? They're both negative numbers here. Okay. -8 is smaller than -5. Remember, on the negative scale, as you go down, your numbers get smaller. So yes, that's what I'm seeing in the chat. We want it to increase. So we want to increase to -5. So remember, if I want my exponent to increase, I need to move my decimal to the left. So what I'm going to do is and I need to go 3 places to the left. So I'm going to take this number down here, move my decimal 3 places to the left. I should get 0.00286. Now I have times 10 to the -5. So I want you to go ahead. I'm going to launch a poll question, and I want you to pick which answer there. I think that's the right one. All right, can you guys see the poll? Okay, take your time. All right, we got about 50% voted so far. So you're taking this first number, Taking this first number and then you're doing whatever kind of math you need to do with the second number and what answer do you get, and that's what you're trying to select here. All right, I'm gonna give like 15 more seconds. Got 10 people left. So if you gotta just guess, go ahead and just throw your answer in. All right, I'm gonna end the poll. We got it, 58 to 58, okay. So the most popular answer was B. I don't know if it gave you A, B, C, or D, but the second choice, 3 point, oh, you can't see. Share results. Now can you see the results? Okay. 3.0181 times 10 to the minus 5. And that is what you should have gotten. So it should be 3.0181 times 10 to the minus 5. Why was it not the first choice? Why is the first choice not correct? Technically, those are the same physical quantity or value. But why can we not choose the first one?
Because of the exponent.
Not because of the exponent, because of the base number.
It's not a number between 1 and 10.
There you go. Not a number between 1 and 10. It's 0.3. Okay. So we want the number between 1 and 10. So it's got to be 3 point. And if you chose, I think the third answer choice, I think you added instead of subtracted. Okay. And you're supposed to subtract. And then the last one, you just picked the wrong exponent. It should have been remember we converted to -5, not -8. Okay. All right. So that was that problem. Any questions so far? I'm going to have another poll in a little bit later on. We get to it. All right. That's addition and subtraction. Let's look at multiplication. Here's the rule. You're going to multiply the digits. You're going to add the exponents. All right. Multiply the digits. This one's, I think this is a little easier. You don't have to do any manipulation with moving decimals. So you're just going to take the base numbers and you're going to multiply those. So you're going to do 7.41 times 4.32. And what do we get? Somebody go ahead and you can throw that in your calculator and shoot me the answer. And then we're going to add the exponents. So we have an 8 and a 10. So when we write our exponent, the times 10 to whatever should be to the power of 18. That's huge. Okay. So, all right. The answer that we're getting here, we're going to have to manipulate this. It's 32.01. But notice this is not a number between 1 and 10. So what do we got to do? We got to move the decimal one more time. I'm going to take my decimal, move it right here. So we'll get 3.201, but we move the decimal one to the left, so our exponent goes up one more time. So this will be times 10 to the power of 19. Okay. You guys go ahead and spend a second on this next problem down below. I'll kind of write out kind of what you should do. 3.021 times 2.86. What do you get? And then you're adding the exponents. So for your exponent part, -5 plus -8. If you get the answer, go ahead and throw it in the chat. Molly said she got 8.64 times 10 to the -13. And this is, if that's correct, this is a number between 1 and 10. So we don't have to move the decimal anymore after this. Is that what you guys got? Okay. Good deal. Thank you. Thank you. Okay. Any questions on these? All right. Last thing. We're going to now look at division. Here, you divide your base numbers or your digits, and then you subtract your exponents. Okay. So for time's sake, we're just going to do this first one so that we can move on into the prefixes and stuff that we need to get to. But if you want more practice, you can come back and do this second one. So let's just do the first one. We'll do or sorry, 7.41. And we're going to divide that by 4.32. And then for your exponent part, you should do 8 minus 10. What do you guys get? $7.41 divided by 4.32. Kylie said she got 1.72. We'll round to that. That's good. And then it should be yes, times 10 to the negative 2. Okay. So that's it for scientific notation for this course. All right. So we're going to put a pin in that. You'll use this as we go on. Definitely know how to do this stuff for the first quiz and the first exam. We're going to change gears though. We're going to go back to talking about units. Okay, so we're going to look a little more in depth at length, three major units that we're going to use a lot. I call these the 3 base units. Okay, that's length and mass and volume. Okay, length, mass, and volume. So we're going to look at the first one. The first major base unit is length. All right. Or it's a property that we can measure, length. It is a measurement of distance. That's what length is. Okay. Now the base unit for length, okay, that we're going to use on the metric system is the meter. Is the meter. Now, read this part in purple. I want you to have a feel for the size of a metric unit. If I say the word meter, some of you can imagine about how far that is, and some of you may not. Oh, sorry, I saw a question in the chat. How far would you like us to round? Pause real quick. When it comes to rounding and like sig figs, I'll tell you this. Your homework, Mastering Chemistry, will probably have you do more work with sig figs than I'm going to have you do, okay? I'm not saying sig figs aren't important. They are important, okay? But I'm not going to really I'm not going to hold you accountable for those in this course, okay? So if you round to 1 decimal place, or I typically like 2 decimal places if you can give me that. But I'm not too worried about rounding, okay? All right, back to this. I want you to have a feel for about how big these units are. So I have a picture here. This is our lovely football field. And here's a yardstick, okay, or a meter stick. If you're familiar with football and, 10 yards is first down, one of those 10 yards, that's what we have marked off here on the field. And that's roughly 1 meter, okay? 1 meter is roughly, in the English comparison, 1 yard. And a lot of you probably already knew that. But that gives you an idea, something you can think of tangibly in your head when we say the word meter. Okay. All right. What about? Oh, by the way, we abbreviate meter with a lowercase single m. 1 lowercase n. That's meter. And it's going to get real confusing with the abbreviations, so try to keep those straight. What if we're talking about a centimeter? Okay. Roughly how big is that? Well, here's a ruler. Okay, you guys should be actually quite familiar with centimeters. And it's roughly the width of your pinky. Okay, so if you hold your pinky up and you look at that, that's about how big a centimeter is. Okay, so width of your pinky. This always makes me think of my husband's grandpa. He's a glass man, so he's worked with really big, heavy pieces of glass, like windows and stuff, his whole life. So I'm not kidding you, his fingers, he wears a size 15 ring, if anybody knows how big that is. So he would be an exception. A centimeter is not the width of his pinky, but a normal human, okay, it might be the width of your pinky. Okay, what about a millimeter? How big is that? If I say 1 millimeter or 10 millimeters, what do you know to think of in your head? So when we look at a centimeter, I'm going to zoom in on this picture over here. 1 centimeter I have marked off in red. Well, that centimeter is broken up into 10 distances. There's 10 tick marks between 1 centimeter. And one of those, the distance between 2 of these little marks is 1 millimeter. Okay, so from here to here, this distance right here is 1 millimeter. And we abbreviate millimeter with 2 little m's. All right, and if you look, a pencil lead is about the width of a millimeter. Okay, 1 millimeter, we abbreviate it mm. So it's the width of pencil AD, sorry. All right. Okay, so that's a little bit on length. Here is a table like I mentioned earlier. Here's just a table. It's all units of length. Okay, so this will help you. I'm going to turn my screen really quick so you can see the whole thing. This is just a bunch of conversions for you. So if you're trying to find the relationship between, and it's got a lot of stuff. It's even got mile, yard, foot, inches down here. So if you need a quick relationship, now obviously if you're working on the homework or a lab or something, you just Google it if you want. But you've got this table here. It's stuff for quizzes and exams that can help you. All right, questions so far on length. We're going to look at mass now. Right, I'm going to turn it back. So mass is another property, and first off, I'll tell you mass and weight are different. And how are they different? Mass is the amount of matter, you've heard that word before, in an object. Weight is a measure of gravity on something. Okay, so your weight may be different depending if you're on the moon or the earth, okay? Anybody know how your weight would be different if you're standing on the moon? It'd be about 1/6 of your body weight on the earth. Yeah, somebody was gonna say it. 1/6. But your mass would be the same, okay? Because the amount of matter in you does not change, all right? Okay, the base unit for mass is the gram. Okay, so we've got the meter for length. If we're talking about mass, though, we're going to talk in units of grams. So how much is a gram? Well, I have a picture over here. If you were to weigh a dollar bill, it weighs about 1.015 grams. So we're going to say about the mass of a dollar bill. Okay, that's about how much a gram is. So not very much, right? A dollar bill doesn't weigh a lot. So a $1 bill. Okay, what about kilogram? Okay, if you have a kilogram, all right, kilo is a word we can put in front of gram, and we're actually going to look at the relationship between these in a little bit, but a kilogram is bigger than a gram. This is the SI unit for mass. How much does it weigh? If I say you have 1 kilogram, what do you know to think? It's about the mass of a loaf of bread, okay? I know you're like, well, that could vary widely depending on what bread you're eating. If you're eating Dave's Killer Delicious 21 whole grains and seeds, where are my dietetics people? Okay, is this the best bread out there? Anybody ever had this bread before? This is actually a picture of my favorite bread, okay? My kids would literally eat a piece of this bread by itself with nothing on it, except for my 7-month-old. He would not, but my 2-year-old would, okay? It is so good. I'm serious. It's also really expensive, so buy it at Sam's, okay? You can buy it in bulk. So loaf of bread. You'll find it's not common. Any place I can find to talk about food in class, I will. So if you haven't had your breakfast yet, I'm sorry. All right, here's a table for mass, just different equivalents, different relationships between units, and you can use that as well. All right, moving on. Let's talk about volume. We're going to get through volume, and then I'm going to introduce a whole list of prefixes, all right? Volume is the measurement of the space occupied by an object. How much space does it occupy? That's a volume. The base unit for volume is the liter. This one's probably way easier for you because very frequently people buy, you know, drinks and different things in units of liters. Okay, a 1 liter Coke, a 2 liter Coke. I have my own favorite example beside the Coke I'll share with you. We measure volume when we're talking about space occupied. The easiest way to measure volume is with we have very special instruments to do this. We have like graduated cylinders, volumetric flasks, okay? We have syringes. We use those tools to measure volume because oftentimes we're working with liquids, right? And real quick, this is kind of you should know how to do this, but if we're measuring volume in some sort of volumetric instrument, you'll often notice that when you go to take the measurement, the liquid is curved, okay? Where should you take that reading? Do you take it over here at the side? Do you take it at the base of the curve, at the bottom? Yes, Emily said that in the chat. This is called the meniscus, and you read it at the base of the meniscus. Okay, I think that most people understand that, but just as a reminder. All right, so how much is 1 liter? Well, the English comparison, my favorite example is with ice cream. Okay, I've already talked about ice cream. I'm just gonna keep talking about ice cream all semester. 1 liter is a quart, okay? 1 quart. But 1 quart is 2 pints, okay? So if you have your favorite ice cream and you don't want to buy a whole half gallon of it, I'm not against that. You buy the whole half gallon if you want. But a quart is 2 pints, okay? Some people may be familiar with a quart of oil for your vehicle. If you want to go to the store and buy a pint of ice cream, 2 pints is a quart, all right? Anybody ever had this ice cream before? Anybody ever heard of Jenny's ice cream? Most people have not, okay? It's a very bougie ice cream, if you want to call it that. You can't buy it at Walmart. I'm very sad about that, actually. You have to go to like, anybody shop at like Whole Foods or Fresh Market or anything? We need more of those in Conway. Would anybody be excited if we got that in Conway? I would, because you can buy Jenny's there. And Jenny's ice cream is literally the best ice cream, but it's not the cheapest. It's really good though. So if you're ever around a Whole Foods, try it out. All right, if we have a liter, that's a quart. What about a milliliter? Okay, by the way, you abbreviate liter with a lowercase l. You abbreviate milliliter with a lowercase m and then a capital L, okay? What is the English comparison for a milliliter? Well, in this little volumetric cylinder over here, graduated cylinder, we have about a milliliter of water, and it's roughly the size of your pencil eraser or just the tip of your pinky, okay? That's about a milliliter, okay? So I'll say pencil eraser. And I'm just talking about the normal small ones. All right, so that is, I think we have one more. No, we don't. I think that's it. But one other thing I want to say about the milliliter. There's one relationship I want you to be very familiar with, okay? 1 milliliter is roughly equal to 1 cubic centimeter, because we can measure space occupied not just in units of like fluid volumetric units. We can also measure volume as a cubic distance, okay? So if you have a shape that is very easy to measure, you can measure the length, the width, and the height. You can multiply those distances and you can get what we call a cubic distance, okay? That is going to tell you the volume of that object as well. It's just that a lot of objects are not easy to measure like that, okay? We can measure cubes and regular shaped stuff, but a lot of things aren't regularly shaped with nice even sides. So we have to use milliliters and liters and things like that. So if we're measuring cubic distances though, 1 milliliter is equal to exactly 1 cubic centimeter, okay? I have a cube right here and it's measuring 1 centimeter on each side. So that is 1 cubic centimeter. And the volume of that cube is 1 milliliter, okay? So please know this. This is gonna be very important for density, okay? When we convey density of objects, we can say gram per milliliter, we can say gram per cubic centimeter. I'll talk more about density later, but please know this relationship because you might see it either way. Just know that they're equal. To give you an idea roughly how big a cubic centimeter is compared to say like a cubic meter, I have this slide. If we have a cubic meter right here, the one in red, it's pretty large, measuring a meter on each side. Well, if we take one of those small cubes, if we break this into 10 equal length cubes on each side, take one of those, now we have what we call a cubic decimeter. And that is equal to 1, I just wrote over it, but that's equal to 1 liter, okay? A cubic decimeter. If we break that into 10 cubes equal distance on each side and take one of those, that is how small a cubic centimeter is. That's how big a milliliter is, okay? just for visual. You don't have to memorize. Don't worry about memorizing these relationships except for that one. All right, here's your table for volume. And that's just, therefore I'm going to skip over it because we really need to get to prefixes, okay? All right, what is a prefix? So we're putting a pause on the gram, meter, liter stuff for just a second. And I'm going to introduce prefixes. In the English language, a prefix is a word that you put in front of another word. So if I say I am Dr. Everly, okay, or Mr. Jones or Mrs. Jones, you understand what those prefixes mean. They tell you if it's a male or a female. They tell you if they have some sort of degree associated with them. That's what happened? That's what prefixes do. Now, scientists often deal with numbers that are very small or very large, okay? Very large, very small measurements. Examples. Our whole world has been centered on things that are this small lately, okay? A virus particle is 0.0000012 meters. Well, it's really hard to comprehend that number in our brain with so many decimal places. But that's how big a virus particle is. Or we could say it's this many meters to the sun. I think that's like 150 billion or trillion even. So because we have so many digits and decimal places, we can use prefixes to make the numbers more easy to read and to communicate. Okay, it makes numbers manageable. I don't know if I spelled that right. You're going to learn that spelling is not my strong suit in here. But you get what I'm trying to say. Manageable. All right. A virus particle is 120 nm. Anybody know what N stands for?
Nano.
Yes.
Nanometer?
Right.
Yes.
Nanometers. Okay. In diameter. If we want to take this number of meters to the sun and make it more manageable, you could say it's 150,000 capital M. We put a prefix with meter, and now we have a megameter. Okay, so a megameter is bigger than a meter, so it's only 150,000 megameters to the sun instead of this large number of meters that we had earlier. Or we could say it's 150 million km. You guys are probably familiar with km. That's a kilometer or kilometer. Say it either way, to the sun. All right, so that's kind of an intro on what prefixes are. We are going to bring back now liter, gram, and meter, and we're going to apply prefixes to these base units. So just remember that the three base units we've already talked about them, are liter, gram, and meter. So we can put prefixes in front of any one of these, in front of liters, grams, or meters. So I've got this figure here, and we're going to walk through it one by one. All of these words that I'm underlining, these are prefixes, okay? Kilo, hecto, deca, deci, centi, milli, micro, nano. These are all prefixes. Some of these prefixes, when you put them in front of your base unit, it makes them larger, okay? And so that's going to be these three up top. These are larger. I'm going to abbreviate, then the base unit. And then the ones down here, these are smaller. Okay, what that means is when you put the prefixes under the red line, when you put those prefixes in front of the base unit, now you have a physical quantity that's smaller than your original base unit. So let's look at the first one, kilo. We abbreviate kilo with a K. 1 kilo, I bet you guys know how many base unit is. If I tell you I paid 10K for a car, how much money did I pay for the car? well, $10,000, right? So a kilo stands for 1,000. So if I have a kiloliter or a kilogram or a kilometer, I'm talking about 1,000 of my base unit. So 1 kilo is 1,000 base units. All right, a hecto, we abbreviate out with an H, is 100 of your base units. And a deca, well, we know a decade is 10 years. And in the sciences as well, deca, we abbreviate that DA, lowercase, is 10 of your base units. So if I had a decaliter, that would be 10 liters, okay? All right, that's the three that are larger than your base unit. That's why it takes multiple of your base units to equal those physical quantities. Okay, now let's go beneath the red line. If we have a deci, these are smaller. So it's going to take multiple of these to equal one base unit. So if I have 10 deci, liters, grams, or meters, I have one of my base unit. Where it says base unit, you can just plug in any one of these top three words up here. We abbreviate deci with just a lowercase d. 100 centi, abbreviate centi with a lowercase c. How many, anybody know for milli, how many milliliters in a liter? Yeah, Kevin wrote it, 1,000. Okay, what about micro? Micro is even smaller. So as I have them listed in order, as you go down, we're getting smaller and smaller and smaller. You can write out all the zeros if you want, but a micro is smaller even than a milli. There is a million. I'm going to write 10 to the power of 6 because I don't want to write all the zeros, which, by the way, you can use scientific notation if you want, if you're comfortable with that. There's a million micrograms in a gram. Okay, there's a million micrometers in a meter. And I'm going to zoom in on this abbreviation. It's a U, but it has a tail on the front. Okay, an extended tail. So don't forget that when you're writing the abbreviation for micro. And then lastly, the very smallest prefix on here is nano. Okay, nano, there's a billion nano units in any unit. So this is 10 to the power of 9, all right? Or you can write it out with all the zeros. It would be 1 and then 9 zeros. Okay. All right, so that's just an intro on prefixes. Different people have been taught prefixes different ways already, especially if you've taken like an AP chemistry course, you may have seen this differently. So I'm going to tell you as we move forward, if you're comfortable writing it different ways, as long as you're communicating the same relationships and they're mathematically correct, I'm okay with that. I'll show you what I mean in just a second. So some people may want to say that 1,000 milliliters is equal to 1 liter, okay? Other people may want to say, well, 1 milliliter is equal to 0.001 liter. Guess what? Those both mean the same thing, okay? So if you were taught it this way and you like that better, that's great. Or guess what? You can write it in scientific notation like I have down here. Some people like writing, it's the same value, same physical quantities, just written out in scientific notation, okay? So if you like that way better as well, that's good with me, as long as your mathematical relationships are correct, okay? Questions so far? All right, we're gonna spend the rest of our time, we got about 15 minutes left, doing some conversions. By the way, a couple of these are pretty common. So here's the deal. Yes, you have open notes for your exams and stuff. I encourage you to memorize 4 of these relationships. I'm going to tell you which ones. That way on exams, you're not having to go look these up. You just know them. Second nature, and exam days are already stressful. So things that are going to save you time are things like this, memorizing these relationships. And here's the ones I would like for you to memorize. Kilo, okay, so knowing this information right here. And I don't just mean for a gram, but this is just an example, okay? So kilo, and then come down here, centi is very common. Milli, anybody work in a hospital as any kind of tech or assistant of some kind, you know that milli is a very common, or even micro. All right, these are the 4 that are so common, you need to know them, Okay, especially if you are gonna go to nursing school or there's more examples besides nursing, but a lot of you guys are nursing majors, so. All right, question. So memorize those those relationships. All right, let's get into some conversions. So what is a conversion? We're gonna spend the rest of our time today learning how to convert between units. And you guys actually do this very commonly, okay? If you have to shop for your own groceries, you do this when you go to buy eggs probably. If I tell you that I want 36 eggs, how many dozens of eggs are you gonna buy? Yes, Kevin wrote 3, okay? We use the word dozen. It's to convert between the unit dozen and individual eggs, okay? Because we know it's very standard that a dozen stands for 12 items, all right? So we're gonna use conversion. Oh, I didn't even finish writing the word. Factors to obtain an equivalent quantity in a different unit, all right? So what is a conversion factor? It's just a physical quantity that relates 2 units. It's just the relationship between 2 units. All right. So we're going to answer these questions over here. In fact, we're probably just going to do 2 of these for time's sake before we move on. So let's look at the first one. Here's my question. If I have 1.36 kg, that is what? What is kg? We have a prefix there. K stands for kilo. Yeah, kilograms. How many grams is this? So as you're doing this, again, this is where people's work is going to differ. And you do it the way that's comfortable to you if you know how to go about these things. The first thing I'm going to encourage you to do is write out the relationship between your units. I have 2 units here. Here's the first unit, kg. Here's the second unit, g, gram. So the relationship there is that 1,000 grams is 1 kilogram, okay? Now, if we're writing it as a factor with a numerator and a denominator, you can write it either way. You can write it with grams on top or kilograms on top. Okay, so I've written these out. I've just taken this relationship and I've written them as factors. I'm going to start with the number that I'm given, which is 1.36 kilograms. I want to convert this to grams. In mathematics, you have to cancel out a unit that you're going to get rid of. We're going to get rid of kilograms. We got to cancel it out, okay? And we're going to convert to grams. So to cancel out kilograms, I'm going to multiply by one of these 2 conversion factors, either this one over here or the one on the right. And I want to cancel kilograms. So because I want to cancel it, the way you cancel things in algebra and in math, you have to have it on top and on bottom, 1 time each. So right now, I have kilograms on top. So I'm going to pick this conversion factor over here. I'm going to plug it in. I'm going to write 1,000 grams on top and 1 kg on bottom. And now I have kilograms on top and bottom. I'll show you how they cancel. I've got it on top, I've got it on bottom, so I can cross them out. That's what I mean by cancel out. Okay. So now I just do the math. How many grams is this? 1.36 kilograms times 1,000. You should get 1,360 grams. If I know that 1 kilogram is 1,000 grams, then I have a 1,360 grams, okay? This is what I mean by a simple conversion, a 1-step conversion, okay? Let's go ahead and do the bottom one. We have 1.23 liters. How many milliliters is this? Take a second. I have the relationship written out for you over here. 1 liter is 1,000 milliliters. Go ahead and work this out the same way I just did with the kilogram problem. All right, Kevin said he got 1,230 milliliters. So how did he get that? 1.23 liters. We want to cancel liters out. So I'm going to multiply it by one of these two conversion factors. I've already got liters on top. So I'm going to pick this second conversion factor because it has liters on the bottom. And I want liters to cancel. So I'm going to write 1 liter on bottom, 1,000 milliliters on top. Because I have liters on top and on bottom, it cancels. And now we just do the math. 1.23 times 1,000. You could divide by this 1 right here, but anything divided by 1 doesn't change your answer. So sometimes if I'm dividing by 1, I just ignore it. And you should get 1,230 milliliters. Okay. There we go. Questions on this? We're about to do a poll question. Let me find, I think I labeled the one that's a poll question. I need to go find it. I have noticed that we have lots of slides here. Next, they're just a lot of practice, okay? So we're gonna do one of these and then we're gonna end with this poll question down here, okay? So let's go ahead and do this one right here. I have more than we can do in this amount of time. So if I don't get to any of these problems, just know this is extra stuff you can practice. I'm not going to post an answer key for these things, but if you work one of these problems and you have a question on did you get it right, just shoot me an email and I'm happy to look at your work or set up a Zoom and we can go over it, whatever. 374, what is this? Remember the U with the tail on the front, this is micro, okay, microliters. And we want to know if we have 374 microliters, how many milliliters is this? Now, I will tell you, some people may want to do this in 2 steps. I'm going to teach you an easy way to do it in 1 step, okay? What you need to do first is you need to relate, here's unit number 1 and here's unit number 2. We have relationships for how these relate to the base unit, and the base unit here is just the liter. So I want you to fill in the blanks. How many microliters is equal to 1 liter? And then how many milliliters is equal to 1 liter? We went over those just a couple slides earlier. And we saw this, that there's 1,000,000, 10 to the 6th microliters in a liter. There's 1,000 or 10 to the power 3 milliliters in a liter. Now, hang with me. If both of these equal 1 liter, which is the same, don't they both then equal each other? Can't we say 10 to the 6th microliters equals 1,000 milliliters because they both equal a liter? Are y'all with me on that? Okay, that holds. So why don't we just now use this relationship? All right. So start with this value right here, 374 microliters. And we want to cancel out microliters because the question wants to know how many milliliters. So I'm going to write this as a conversion factor. And I want to cancel microliters, so I'm going to write microliters on bottom. So I'm going to put 10 to the 6 microliters on bottom equals 1,000 milliliters on top. So we'll do 374. And notice the math here. We're going to do times 1,000, but I have 10 to the power of 6 on bottom. What do I do with that? I have to divide by that number. Anything that's on bottom, like under, when you draw in your conversion factor, when you draw this line, anything on the bottom, you have to divide by that. Anything on top, you have to multiply by that. So you're literally in your calculator going to do 374 times 1,000 and then divide by 10 to the power of 6 or 1,000,000. You could put in 1,000,000. And what do you guys get? 0.374 milliliters is what you should get. Great. All right, we got about 5 minutes left. So I'm going to have you do this last problem. I'm going to launch the poll and you'll put your answer in. And that'll be it for today. So here's the problem. We have this many nanograms. That is 578,965 nanograms, okay? And we want to know how many micrograms in this. Remember, micro is this symbol right here, micrograms. So I'm going to pull up the poll. Go ahead and start writing your relationships out. If you need to go look at the slides where we had this stuff written out, go find that slide and see what is my relationship to the base unit, which is just the gram here. All right. When you get your answer, you go ahead and select one of these. So you need to write out relationships. How many nanograms is equal to 1 gram? How many micrograms is equal to 1 gram? If you can answer that, then we can write a relationship directly between nanograms and micrograms. You can go look at that table on mass if you want, but I doubt you're going to find a relationship for directly between nano to micro, but you might. So you should have 10 to the power of 9 to the power of 6. So remember, if they both equal 1 gram, you can say this, 10 to the 9 nanograms equals 1,000,000 micrograms. And there is your relationship. So you should have done 5, 7, 8, 9, 6, 5 nanograms. Remember, you're going to write in times your conversion factor. You want nanograms to cancel. So you should have put 10 to the 9 nanograms on bottom, 10 to the 6, 1,000,000 micrograms on top. And now that we have nanograms on top and bottom, they cancel. I like to put things, by the way, in parentheses when I do exponents and stuff in my calculator, because you're literally going to take this value, multiply it by 1,000,000, divide it by 1,000,000,000. Okay, about 50% of you guys have put your answer in. We've got about 2 minutes of class left, so go ahead. If you've got a guess, just go ahead and guess your answer. I just want to show everybody the answer to this before I end lecture for the day. All right, 90% have voted. I'm going to end the poll. If you didn't get your answer in, it's okay. It's okay. This is not for a grade. And share results. So the most commonly picked answer was the last one. And that's correct. Okay, so when you do all of this in your calculator, you should have ended up with 578.965. And the unit there is micrograms. Okay. If you got one of the other answers, it could have been that you put 10 to the 9 on top, 10 to the 6 on bottom, or somehow you didn't type it into your calculator quite right. So just double check your math there, but that's what the answer should have been. questions on that? Okay, well, guys, that is it for today. So thank you all for joining. If you have any questions, I like to keep the Zooms open for a couple of minutes. Make sure you're paying attention to the lecture schedule. I'm going to pull, well, I stopped sharing my screen, but look on the syllabus at the lecture schedule. I think we have a quiz. Quiz 1 is going to be next Tuesday, okay, on Blackboard. And so what that means is I'm going to open up the quiz probably right after our first lecture, and it'll be open pretty much the whole day. So you can get on there, take the quiz. It's just going to be 5 multiple choice questions. It'll be on the content we covered all this week. So it could be stuff from Tuesday. It could be stuff from today. And you'll just put in your answers for those 5 multiple choice questions and hit submit. You'll have about 20 minutes to do the quiz. And that'll be how quiz 1 will go. That's how all your quizzes will go. Make sure you have a calculator for that. It's open note, open book.